Hello everyone. In this project, we are going to detect the plant leaf diseases using machine learning. So basically deep learning. So first of all, we are going to import some packages required for this detection or for this project. So first of all, we are going to import TensorFlow STF, Matplotlib, which is basically used to represent or like visualize the data, and TensorFlow.keras. From TensorFlow.keras, we are importing models and layers and all. So first of all, we run pip install TensorFlow. I'm using basically my GitHub repository because it took a bit longer to install the packages and running epochs. So in order to avoid that hassle, I'm just using my Google GitHub repository. So here I actually do not need to run the data. It is already prepared. So you can just go through it and use that on your own machine. So here we are defining the image size, batch size, channels, and epochs. I'm going basically using 15 epochs, and you can use that on your own. So first of all, we get our data set for the image preprocessing. Preprocessing is very important step. So because we have to like make the image of similar patterns so that machine can recognize and act properly with them. So first of all, we are going with image processing with batch size 32. We have predefined that, and then we see that 4188 files are there in the data set. So next, we are class names. We are going to check the class names. So they are basically bright, common, rest, gray leaf, spot, and healthy. Length of the data set is 131. And let's check some images of the data set. So this is basically the Python code for picturizing some images from the data set. You can see healthy images. They are like pretty good light. They are having some gray spots, so they're common rest and gray leaf spot. So these images are having like basically all the samples from the all parts of the data set. Here we are breaking the data set into training data set and testing data set. So you can see that length of the training data set is 104, length of the validation data set is 13, and length of the test data set is 14. This is basically the code for like partition, for breaking it down into multiple sets so that we can actually train the model, validate the model, and test the accuracy and the quality and working of the model. So here basically we are having train data split as 0.8, validation split as 0.1, and test split as 0.1 only. The sum is going to be 1 only. So here we are using TensorFlow auto tuning on the prefetch data set or data. Here we are like doing some sort of pre-processing. We are rescaling the images so that it converts all the images of the similar sizes. So I have told you before that it is basically required for the machine to work properly. Then you can go you can see data augmentation. Data augmentation is basically the process of generating more images of the same data set in order to compensate the lack of images. If you are having some sort of lack of images or something like that, you can augment the data. It multiplies the images by some means. So here we can see the model. This is basically the model. These are basically the layers of the model, and this is the neural network CNN, and you can see the structure of the CNN. This is the basic structure, and in the next step we are going to see the summary. This is summary of the model. Here we do compilation process. Here we compile, and we are using accuracy as like parameter of its effectiveness or something like that. Yeah. So here we are going to fit the data, train the model on the data. You can see model.fit. So it is going to take 15 epoch. It took a bit longer than required because it varies on the system by system. You can use GPU to increase the speed of this process. So after training, you'll see that model has required like 89. Model has got like 89%, roughly 90% accuracy. Validation loss is 29%, and yeah, the accuracy is here. You can see the accuracy of the model on the test data set. It's like 88.84%. Now let's check if it is working properly on some sort of images. So this is basically the code. This is the code for generating for predicting image for first predicting like label for the first image. This is the code. So actual label is bright and the predicted label by the model is also bright. So we can see that our model is working well and good. Now let's take it to the like next level, and now we are going to predict like the same thing for 15 images. So this is the code for 15 images. So here you can see that more actual is healthy, predicted is healthy with the confidence level 99%. Higher the confidence level is, more confident the model is about the prediction. Here you see actual is gray leaf spot, but the predictor is common rust. So like somewhere it is showing less confidence. That means the model wasn't much sure about the prediction, and it is wrong obviously, because it is not going to get 100% accuracy. So you can manipulate, fine tune the model on your own data set to check. You can manipulate the layers of the neural network to get the more accuracy, some sort of more feature extraction, proper feature extraction, so that, and you can use undersampling, oversampling to balance the data set, so that all the images from the testing data set, all images of various parts of the data set are roughly equal. So you can increase the accuracy by various means. And yeah, that's it for the project. It's working well and good, but we can increase the accuracy. 88.85 is decent accuracy, but we can increase it up to 95-96% by increasing the epochs and changing the various parameters. So you can use the code and run it on your own machine. Thank you.